Welcome back everyone to another video on the tangent and velocity problems. My name is Ahmed and today we're going to tackle down this problem. We want to find an equation of the tangent line to the parabola y is equal to x squared minus 3 at the point that's given, which is 1, negative 2. So before we start, we have to figure out what the problem is asking of us. So we want to find an equation of the tangent line. Specifically, we want to find an equation of a line. So we need the formula for the equation of a line, and that's point-slope form of a line. And that's given as y minus y1 equal to m, which is the slope, times x minus x1. Where y here is your y coordinate, x1 is your x coordinate, and m is your slope. Now that we have the point-slope form, we realize that we need two things. We need a point, and we need a slope. Well, the point here is given. It's a 1, negative 2. We need to find the slope. How are we going to do that? Well, in order to find slope, we know that slope is defined as the change in y over the change in x. And we get that change function from the equation of a secant line, which is the change in position over the change in time. That's equal to average velocity, like we talked about in the previous video. But now we're using points here. There's still 2 points on the graph to calculate slope, and so therefore the slope of the secant line is equal to the change in y over the change in x in this circumstance. Well, we have one of our points. Our point is a 1, negative 2. We need another slope. We need another point in order to solve this problem. We need a b point. Well, we don't know what that point is, so how are we going to figure it out? Well, I can write this in a way that I can get every single slope of this equation. And the way I do that is I write it in terms of x. So for my point B, I'm going to take any x value that I have on my graph, any x value, and my y is going to be the output, just a simple xy coordinate that we have on our graph. Well, I know what y is here. Y is defined as x squared minus 3. So I'm going to replace point B with x squared minus 3. Now I have 2 points. This point is defined on my curve. This point generalizes every point on my graph. And so I can use the slope equation for the change in y, which is equal to y2 minus y1 over x2 minus x1. Well, what's my y2? My y2 is x squared minus 3 minus, what's my y1? It's negative 2, use parentheses, over my x2 is just x, my x1 is just 1. And this is equal to the slope. Now, when we go to solve this, we have the slope is equal to x squared minus 3 plus 2 is minus 1 over x minus 1. And we know that this factors into x minus 1 times x plus 1 over x minus 1. And we notice that these two are going to cancel, leaving me with my slope equation, which is x plus 1. Now, what does that tell me? That tells me that for any point on my graph, y is equal to x squared minus 3, my slopes are x plus 1. For any x value on my graph, I plug it into this formula, and I get that slope at that point. Well, I know which point that I want the slope at. I want it at the point 1, negative 2, where my x value is 1. So I take my slope equation, which is x plus 1, and I plug in the point that I want, which is 1, and I get that the slope at that point, 1, negative 2, is 2. Now I have my point, now I have my slope, so I can combine it into my point-slope form equation, and that turns into y minus my y1 value is negative 2. My slope is 2 times x minus 1. And you can take this form and put it into different forms, but usually for this sake, for the tangent line, point-slope form works out very nicely. Simplifying this, I get y plus 2 is equal to 2 times x minus 1. And this is your answer. This is the slope of the tangent line, or the equation of the tangent line, to the parabola at that specific point. And that's it for how to tackle this problem. On to the next one.